Siya ba ito? Actually, ito may interview.
Para sa
Alam mo kung ba yung senior program Simplex method?
Oh!
Alam niyo kung ba yung senior program Simplex method? Sure. Kaya bakit ako interview? Kuya, pwede ka ba ma-interview? Kaya lang ka ba sa linear programming Simplex method?
meron na.
Pwede mo po ba kasabi sa akin?
Yung simplex na ito, mahirap yun eh.
May alam ka ba sa linear programming Simplex method? Ate, pwede ka ba ma-interview? Ikaw ba saan? Kaya alam ka po ba sa linear programming Simplex method? Linear, graphical method lang. Ano po yung graphical method? Graphical method yung magamit ng graph, but then again, Okay, pwede ko pong ma-interview. Wala naman po ba sa linear programming Simplex method? Graphical. Ay, ano po yung graphical? Gusto po ba yun? Dami super. Ano po ba yung graphical method? Graphical ng graph. Thank you po. Good evening. Mga ate, kuya, pwede mo kayo ma-interview? Ladies, ako kami bisita. Bawal. Salamat po. Ay, alam ko po ba sa Simplex method? Linear programming. Check out. Check out. Ito yan.
Hindi kaya yung Simplex.
Ito, linear programming.
Pero hindi simplex.
Oo.
Complex na to.
Ganyan po ka-stress ang Simplex method. Pero hindi yan Simplex method. Linear programming.
Maging accountant.
From to accountancy to. Magiging accountant sila.
Linear programming, also called linear optimization, is a method to achieve the best outcome, such as maximum profit or lowest cost, in a mathematical model whose requirements are represented by linear relationships. It is a technique for the optimization of a linear objective function subject to linear equality and linear inequality constraints. The first linear programming formulation of a problem was given by Leonid Vitalyevich Kantorovich in 1939, who also proposed a method for solving it. He developed it during World War II as a way to plan expenditures and returns so as to reduce costs to the army and increase losses incurred by the enemy. About the same time as Kantorovich, T.C. Koopmans, Dutch-American economist, formulated classical economic problems as linear programs. Kantorovich and Koopmans later shared the 1975 Nobel Prize in Economics. In 1941, Frank Loren Hitchcock also formulated transportation problems as linear programs and gave a solution very similar to the later Simplex method. He unfortunately died in 1957 and the Nobel Prize was not awarded. During 1946, George B. Danzig independently developed general linear programming formulation to use for planning problems in U.S. Air Force with only a desk calculator. In 1947, Danzig also invented the Simplex method that for the first time efficiently tackled the linear programming problem in most cases. Danzig's original example was to find the best assignment of 70 people to 70 jobs. However, without an objective, a vast number of solutions can be feasible, and therefore, to find the best feasible solution, military specified ground rules must be used that describe how goals can be achieved. They reduce the number of possible solutions that must be checked. With Danzig's method, it takes only a moment to find the optimum solution by posing the problem as a linear program and applying the Simplex algorithm. In the 20th century, the Simplex method is recognized as one of the top 10 algorithms. Post-war, many industries found the use in their daily planning.
In the clip you have just shown, there are different methods in finding for the value of unknowns that will give you the best outcome. First is the graphical method. There are three parts in linear programming. First is the objective function, second is the problem constraint, and third is the non-negativity constraint. Step 1. Graph your linear equation. In order for us to graph our linear equation, we need first to find the value of x and y intercept. Here in our example, we have already find the value of x and y intercept. Step 2, solution set. Substitute any point in each function constraint. But to make your life easier, you can use 0, 0 provided that the line doesn't pass through the origin. If the result is true, the solution set will move toward the test point. Or otherwise, it will avoid the test point. The solution set is now the intersection of the three planes and non-negativity constraint. In our problem, we have to take note that we have to avoid the left side of the Cartesian plane because we have a non-negativity constraint of x1, x2 is greater than or equal to 0. Step 3, point of intersection. We have already two known point of intersection, which is the 0, 11 and the 27, 0. We still have two unknown intersection, which we need to compute for the point of intersection that bounds our solution set. We have already found the two unknown point of intersection by the process of elimination and substitution method. Here are the points of intersection. Step 4. Substitution to objective function. To find which of the combination points will give you the maximum and minimum value, substitute the point of intersection to your objective function. Reminder that if the solution set is unbounded, there is no minimum value, only maximum. So, the maximum value is 132 while the minimum value is 66.
But the graphical method is not always efficient and may be time-consuming, especially when there are already a lot of constraints and unknowns. In such cases, we can use Tan6 Simplex method to find for the maximum and minimum value of your linear programming problem. However, here in our tutorial video, we are only going to solve for the former, which is the maximum value of your linear programming problem. So, using the same given as the one in our graphical method, the first step is to add a slack variable to each of your problem constraints. The number of the slack variables will depend upon the number of your problem constraints. Since there are 3 problem constraints here in our given, excluding the non-negativity constraint, there are also 3 slack variables denoted by S sub 1, S sub 2, and S sub 3. A slack variable is a variable introduced to the left side of the equation, turning the inequality to an equality. The value of a slack variable is that which makes the left side of the equation equal the right. Your objective function should also equal to 0, which is why we need to transpose 4x sub 1 and 6x sub 2 to the left. Step number 2. Make use of your new equation by inserting them inside the matrix, specifically the coefficients and the constants. Solving this is like Gauss-Jordan elimination, however, there are some change in rules. In Gauss-Jordan elimination, we take the leftmost element of the matrix and turn it into 1. However, here in the simplex method, we have to take into account the pivot element first.
What is a pivot element?
The pivot element is the intersection of the pivot row and the pivot column. In determining for the pivot column, it should contain the lowest negative in your last row. So here in our example, since negative 6 is lower than negative 4, negative 6, the column that contains it, is now the pivot column. To find the pivot row, we have to divide the constants by the elements in your pivot column. The one that will yield the smallest quotient, smallest positive quotient to be exact, will be your pivot row. In our example, we need to divide C by x sub 2. So, 11 divided by 1 is 11, 27 divided by 1 is 27, and 19 divided by 5 is 18. Since 11 is the smallest among the 3, the first row is then our pivot row. Again, the intersection of our pivot row and pivot column is our pivot element. We don't need to multiply the entire row by a certain number since the value of our pivot element is already equal to 1. Step number 3. Like in Gauss-Jordan elimination, we need to turn all the other non-zero elements of your pivot column into 0, which is why we need to turn 1, 5, and negative 6 into 0 as well. In order to do that, we have to multiply the entire row 1 by negative 1 and subsequently adding the answer to row 2. Multiplying negative 5 by row 1 and subsequently adding the answer to row 3. And lastly, multiplying 6 by row 1 and adding the answer to the fourth and last row. Take note that you need to apply the formulas you have come up with to your entire matrix and not just the other non-zero elements of your pivot column. Step number 4. After that, you have to exit the variable of the pivot column and then enter it to the pivot row because this will help you determine the value of the unknowns in the end. Step number 5. The process will continue until there are no more negatives in our last row. Since we still have negative 10 in our last row, a negative number, we have to repeat the first 4 steps again. We can see that there is another negative number in our last row, or negative 8/7, which is why we have to compute further. Since there are no more negatives in our last row, this is now our final matrix which contains the final answers. Hence, x sub 2 is equal to 12, x sub 1 is equal to 14, and x sub 1 is equal to 15. Now we have come to the 6th and last step of the simplex method. The element on your bottom right should be the Pmax, or the maximum value of your linear programming problem. The Pmax here in our given is 132. We can see that the Pmax of the graphical method and the simplex method should yield the same answer. If we insert these answers to our first equation with an inserted slack variable of s sub 1, we can prove that the slack variable indeed has a value that will make the left side of the equation equal that of the right. But have you ever wondered if optimization has of any use in real life? Well, as a matter of fact, it has many practical uses. It is used in economics and company management to maximize profits and minimize costs with limited resources. Here are more examples to show you more practical uses, especially in our daily lives.
Baker LYZA has to make cheesecake and pandan bread for her bake shop. A cheesecake requires 2 cups of flour and 2 eggs, while a pandan bread needs 3 cups of flour and 1 egg. But Baker LYZA has a problem. She only has 12 cups of flour and 8 eggs. She makes 2 pesos profit per cheesecake and 2 pesos profit per pandan bread. To maximize profit, how many of each type should she bake?
PBCC. Two cups of flour, I have 2 eggs. Cheesecake. 3 cups of flour, I have an egg. Pandan bread, cheesecake. How much is she gonna bake?
In solving worded problems, you should identify which is the objective function and the constraints. But in order to arrive at those equations, you should arrange all the necessary data in the form of a table. As mentioned in the problem, a cheesecake required 2 cups of flour and 2 eggs. In the pandan bread, it required 3 cups of flour and 1 egg. So, Baker LYZA has a total of 12 flours and 8 eggs. The profit for each type of cake is 2 pesos. So, to get your objective function, always have in mind what the problem requires to be maximized. So, the Pmax will be As for the problem constraints, identify the limitations stated in the problem, and also do not forget to include the non-negativity constraints. After that, we can now solve the problem using the Simplex method. First, we should insert the slack variables. You should arrange the data in a form of a matrix. So, your x of 1, x of 2, x of 2, and your constant. Third, you should now identify the lowest negative, but as you can see, there are two numbers who has the least negative, so this negative 2, and then you're going to choose either of them and it will still yield the same answer. I'm going to choose this one. Then after choosing the pivot column, you can now proceed with the pivot row. So in order to get the pivot row, you should divide the constant with this one. So 12 divided by 2 is 6, plus 8 divided by 4, 2 is 4. So this is your pivot row. Now we're going to turn this to 1, so we're going to multiply it by 1/2. So 1, 1/2, 0, 1/2, 0, and 4. Then we're going to turn this 2 into zeros. So 2 are Then we're going to multiply this 1 by negative 2 and then add it with 2. So 0. Then we will continue the process. So we'll be doing what we have done with the previous matrix. So 4 divided by 2 plus 4 divided by 1/2 is 8. Then this is our pivot row. As mentioned before, we will going to exit the variable in the pivot column and enter into the pivot row. So this row will be your new x1. So it's 1. And then we're going to do the same on the second matrix. So x2 will become the new first row. So wait. X1. And then we're going to multiply 2 by 1/2 in order to get 1. So 1/2 are 1. So 1 is. And then we're going to turn 1/2 to 0. So we're going to multiply the first row with negative 1/2 and then add it with the second row. And then lastly, we're going to turn negative 1 to 0. So we're going to multiply positive 1 to the first row and then add it to the third row. As you can see, there are no more negative numbers at the bottom, so it means it's the final matrix. So our x sub 1 will be 3, x sub 2 will be 2, and our P max is 10. So our x sub 1 here is the cheesecake, because the x sub 2 is the pandan bread. So Baker LYZA will now have to produce 3 cheesecakes and 2 pandan breads in order to get a maximized profit of 10 pesos.
Painter Kendrick has to submit his entry for a poster making contest tomorrow. However, he suddenly lacked red and green paint to make the color brown. Each unit of color red requires 4 units of color A and 1 unit of color B. And each unit of color green is a mixture of 1 unit of color A and 6 units of color B. Painter Kendrick has exactly 32 units of color A and 54 units of color B. Find the maximum number of gallons he can mix.
RBGP. For color A, 1 color B. Color red, 1 color A, 6 color B. Color green, color red, color green. How much is he gonna mix?
Again, to make it easier to understand the situation, we must make a table of all the facts given in the problem. It was stated that color A contains 4 units of red and 1 unit of green paint. So, color A contains 4 units of red and 1 unit of green. And it was also stated that color B contains 1 unit of red paint and 6 units of green paint. So, color B contains 1 unit of red paint and 6 units of green paint. But it was also stated that Painter Kendrick only has 30 units of red paint and 54 units of green paint. So, 32 units of red paint and 54 units of green paint. Now that we have a table, from it we can find the parts of the linear programming, which is the objective function, problem constraints, and non-negativity constraints. So, let us represent that red paint be x sub 1 and green paint be x sub 2. To get your objective function, always have in mind what the problem requires to be maximized. So, the problem to be maximized is the number of maximum gallons of mixture of colors of A and B. So, P max is equals to x sub 1 plus x sub 2. As for the problem constraints, identify the limitations stated in the problems. In the problem, it was stated that Quendrick has 32 units of red paint and 54 units of green paint. So, it is subjective to 4x of 1 plus x of 2 is less than or equal to 32. X of 1 plus 6x of 2 is less than or equal to 54. And always have in mind to include the non-negativity constraint, which is x of 1, comma x of 2 is greater than or equal to 0. After that, we can now solve the problem using the simplex method. First, we should insert the slack variables. So, 4x of 1 plus x of 2 plus s1 is less than or equal to 32. X of 1 plus 6x of 2 plus s of 2 is less than or equal to 54. Negative x of 1 minus x of 2 plus b is equal to 0. Now that we have inserted the slack variables, you should arrange the data in the form of a matrix. So, 4, 1, negative 1, 1, 6, negative 1, 1, 0, 0, 0, 1, 0, 0, 0, 1, 32, 54, and 0. Third, you should now identify the lowest negative. But as you can see, we have two lowest negative in the last row, which is negative 1. So, you can choose either of the two, and either one will give the same answer. So, I will choose this one. So, after identifying the pivot column, which is the row of negative 1 in this column, is that we can now proceed with the pivot row. By identifying the pivot row, we must divide the constant with x sub 2. So, 32 divided by 1 is 32. And 54 divided by 6 is 9. So, our pivot row is this, since it bears the lowest answer. Now we're going to make 6, which is the pivot element, into 1 by multiplying row 2 to 1 over 6. So, 1 times 1, 6 is 1, 6. 6 times 1, 6 is 1, 0, 1, 6, 0, and 9. Now that we have done this, we're going to make 1 and negative 1, which is the pivot column, into 0 by multiplying negative 1 to R2 by adding it to R1. So the answer would be 3, 4, 5, 6, 0, 1, negative 1 over 6, 0, and 50. Then we're going to apply to 0, negative 1 by multiplying positive 1 R2 plus R3, where the answer will go to negative 5 over 6, 0, 0, 1 over 6, 1, and 9. Then, since we still have a negative in the lowest row, we're going to make it become our pivot column and apply again by dividing the constant with x sub 1. And before I forget is that x sub 2 exits the pivot column and enters into the second row. So this becomes x sub 2. Then continuing with the problem is again, we're going to find the pivot row by dividing the constant and the row of x sub 1. So 23 divided by 3 and 5, 6 is equals to 6. And 9 divided by 1, 6 is equals to 54. Since 6 is the lowest positive number, this is our pivot row. So we're going to make our pivot element, which is 3, 5 over 6 into 1 by multiplying it to 6 over 23 R1. So the answer would be 1, 0, 6 over 23 negative 1 over 23, 0, and 6. And after that, we're going to make 1 over 6 and negative 5 over 6 to become 0. So, since there is no longer a negative variable or element in the last row, the answer would be x sub 1 is equals to 6, x sub 2 is equals to 8, and p max is equals to 14. Sorry. So, Painter Kendrick needs 6 red paints and 8 green paints in order to produce a maximum mixture of 14 gallons of color A and B.